Hi everyone, welcome again to today's tutorial. And today we'll be deriving the equation of a circle. Now the first question is you ask yourself what a circle, and before we could get the definition of a circle, we need to know what a locus is. A locus is a line drawn from a fixed point. Now this line is drawn from a fixed point. This point here is fixed. When we set this line on motion, just like this, it will move from the fixed point to all direction from here, which will eventually form a circle. Don't mind my circle. Now, to derive the equation of a circle, we need to have a Cartesian coordinate. As if we are having our y and x axis, y and our x axis. Now, this equation we are here to derive is the equation of a circle from its origin. Now, if I'm having a radius to point P, remember this is our origin 0, 0. Now, this P, we draw a line to the x-axis, x. Now, this line here is same thing as our y, and the distance between this point and this point is our x. Now, line from the origin to P, let's call it R. Now, to get our x and y relationship with these two, we need to use our Pythagoras theorem, which is r squared is equals to s squared plus y squared, and our r is equals to the root of x squared plus y squared. Now, this is the equation of a circle from origin 0, 0. For the equation of a circle that is not starting from the origin, so for this one we are going to have a point in any place in the Cartesian coordinate. Then we have our circle. Don't mind the circle. Let's imagine this as a circle. And remember, we do this from our locus rather. Now let's call this point A, B in the Cartesian coordinates. Now we want to derive the standard equation of a circle. Now we take this point down to the x axis in the Cartesian coordinates, directing it straight down here. Remember, we are having this here. We take this point here, and also from this point we take it down here. Also with this, we trace this down here, and we trace this down here. Now, the distance between this point to this point, since this is our x and this is our a, will be x minus a. Now, the distance between this point and this point will be y, and this side will be b. Then we can call here y minus b, also y minus b, and this is our radius. Now let's go. From our Pythagoras theorem, we know that r squared is equals to x squared, and our x here is x minus a, which is equals to x minus a squared plus, and our y here is y minus b squared. That is, our r is equals to the square root of x minus a all square plus x minus y rather minus b all square. Now, taking this to this point, I'm having r squared is equals to x minus a squared plus y minus b all squared. We are just taking this one down here. Now let's expand this. I'm having r squared is equals to, this is a squared minus 2ax plus a squared, and this will be plus y squared minus 2by plus b squared. Now, collecting like terms, I'm having r squared is equals to s squared plus y squared minus 2ax minus 2by plus a square plus y square. And finally we equate it to, this is b. Finally we equate it to 0. Then I'm having x square plus y square minus 2ax minus 2by plus a square plus b square. We are minusing r square from both sides, and I'm having minus r square is equals to 0. Now the final step we have to take is that we make g equals to minus a and f is equals to minus b. Now anywhere we see minus, remember this here, this minus 2ax is same thing as 2 times minus a times x. So the a is carrying the minus on behalf of the same here, the same thing as 2 times minus b times y. So let's apply this here. Now I'm having x square plus y square plus, because we are replacing it with a positive g, plus 2gx plus, we replace negative b with f, making it positive, plus 2fy plus a square plus b square minus r square, and they are all equals to 0. The final step we need to do is that we make a square plus b square minus r square equals to c. So we are having x square plus y square plus 2gx plus 2fy plus c is equals to 0. Now this is a standard equation of the circle. This is the equation of a circle with the center minus g and negative f. Why is it negative g and negative f? Since we are having a and b here. Remember that at this point we replace negative a with g, and from negative a equals to g, a will be equals to negative g, and from negative b to f, b will be equals to negative f. That is why we are having this here. And the radius of this circle, we will get it from a square plus b square minus r square equals to c. Now we make radius subject of formula to be r square is equal to a square plus b square minus c. Now the radius will finally be the square root of a square plus b square minus c. This is the radius of the circle, and this is the center of the circle. Finally, what I want us to take note of in a circle, to notice or to identify the equation of a circle, you should note that the power of x and y should be of the power of 2. For example, x square, y square. It shouldn't be the power of 3 or 4, just the power of 2. Another thing we should take note of is that the equation of the circle has no xy term. Example, 3xy. There's nothing like that, or 4yx in the equation of the circle. And finally, the coefficient of x square must be the same as that of y square. And if I'm having 3x square, it should be plus 3y square plus 2gx and so on. Thanks for watching today's tutorial. Don't forget to like and subscribe. And there is another video we made on this that will help you solve more on equation of a circle. Thanks for watching one more time. Stay blessed.